So I wanted to tell you a little bit about hyperbolas before we study about them in class. So this is going to be part one, where I'm going to talk about the hyperbolas with the center at the origin, so objective one. And we'll talk about the asymptotes. But then in the second movie, I'll talk about analyzing hyperbolas with the center at HK. And we're not really going to have any time to look at applied problems, although those are the most interesting problems, but we're running out of time. So first, let's look at hyperbola with the center at the origin. So as with the ellipse, the center of the hyperbola is not a point on the graph of the hyperbola. The hyperbola is these two blue pieces that continue on in both directions infinitely. That is the graph of the hyperbola. So let's talk about the parts of a hyperbola. The hyperbola has a transverse axis that goes through focus, vertex, center, vertex, focus. So remember, with the ellipse, it went vertex, focus, center, focus, vertex for the ellipse. So this is a little different order: focus, vertex, center, vertex, focus. So the line that goes through all those points is called the transverse axis. It cuts through 2 points on the graph called vertices, the 2 focus points called foci or foci, and the center. The line that's perpendicular to the transverse axis through the center is called the conjugate axis. So we don't usually worry too much about that axis. The center is, again, the central point. Notice all the symmetry that's going on with the hyperbola. You can fold it across the conjugate axis and it matches up. You can fold it across the transverse axis and it matches up. So it has twofold symmetry, we call that, about the center. Then we have vertices, which are, again, points on the graph. So vertices are points on the graph, just as with the ellipse, the vertices were actual points on the graph. The foci were not, but they were important points on the ellipse. The foci on the hyperbola, again, are not points on the graph, but they are important points, and notice they're inside the curved part. So when we had a parabola with a focus, inside the curved part. Ellipse, focus, inside the curved part. Hyperbola, focus, inside the curved part. Then another feature that hyperbolas have are called asymptotes. So we've studied about asymptotes before: horizontal asymptotes and vertical asymptotes and slant asymptotes. Well, these are going to be slanted lines, but there's going to be 2 of them, and they're lines that the hyperbola approaches as it gets farther away from the center. So those are going to be the asymptotes that we're going to find. So that's the new feature about hyperbolas. So ellipses had center, vertices, and foci. Only hyperbolas have asymptotes. And then we talked about the 2 branches or 2 arms that are the blue parts. That's the graph of the hyperbola. So there's a definition for the hyperbola. It's a set of all points where the difference of the distances from the 2 foci is a constant. So if you pick any point on the hyperbola and you measure the distance to focus 1 and the distance to focus 2, the difference in those 2 distances is a constant. In the ellipse, it was the sum of the 2 distances was a constant. So notice that the equation for the hyperbola has a minus in it because the definition is a difference in distances, so those are related. So this is a hyperbola where the transverse axis is the x-axis. So see how it's aligned where it opens right and left. The hyperbola touches the x-axis. It cuts through the x-axis. It doesn't touch the y-axis here. So the centers of the origin, we have foci at negative C0 and C0, where this C squared is now A squared plus B squared, the sum of these denominators. So hopefully you've been studying and you remember that the little c squared for the ellipse was the difference of the denominators. Well, now the equation of the hyperbola looks almost just like the equation of the ellipse, except for the minus sign in the middle. So the minus sign goes with the hyperbola equation, then the plus is in the c squared equation. So it also helps if you think about that this distance is a from the center to the vertex. Well, if c squared equaled a squared, the focus would be on the vertex. So we need to add something to a to make it bigger to get the focus in the right place where it needs to go. So just as with the ellipse, you look under the x term and go plus a and minus a in the x direction. Then in the y direction, you're going to go plus or minus b. But we're going to talk more about what that b gets you, and it's going to be that rectangle that we started talking about on Monday. So if your hyperbola opens up and down, it cuts through the y-axis, the vertices are on the y-axis, and the y term comes first. When you have a difference, the order matters. So the y squared comes first if the hyperbola opens up and down. We still have c squared equals a squared plus b squared. We still look under the y term to go plus or minus a. We look under the x term to go plus or minus b, and we'll talk more about what the b does for us. Okay, so the b is going to tell us about the asymptotes of the hyperbola. So if we have a hyperbola, and suppose it looks like x squared over 9 minus y squared over 25 equals 1. Well, then we know from the ellipse that we go 3 in the x direction, negative 3 in the x direction, 5 in the y direction, and negative 5 in the y direction. But now we're going to make this rectangular box where those 4 points are the midpoints of the sides of the rectangle. Then you're going to draw the diagonals of the box, and they should go through the center. It's kind of hard to do without a straight edge. So the asymptotes should go through the corner of the box, the center, and the diagonal corner of the box. So the diagonal corners of the box. So now let's look at what we've drawn. In the x direction, we went 3 and negative 3. In the y direction, we went 5 and negative 5. So let's look at the slope of this line. And you see that you go up 5 over 3. So the slope is 5/3. So the equation of that line, so we write asymptotes by writing the equation of the line, it's y equals 5/3 x, because the y-intercept is 0 at the origin. So that's the slope of the line with the positive slope, y equals 5/3 x. But now notice if you look at the other line, it's up 5, backwards 3, so the slope of this line is negative 5/3. So the slopes will always have that relationship to each other. So the other asymptote will be negative 5/3 x. So notice that these are not perpendicular to each other. They're opposites of each other. So positive 5/3 and negative 5/3 are the asymptotes. Now this hyperbola that I wrote, we see cuts through the x-axis, so we know it opens right left. But if we wanted the up-down, we would just reverse the order of the two terms. But the rectangular box and the asymptotes would be exactly the same. Okay, so let's look at some examples. And analyze the equation will mean find the center, transverse axis, vertices, foci, and asymptotes of the hyperbola. So I'm going to look at the first one, number 30. And I see under the y term a 16, so I'm going to go plus or minus 4 in the y direction and make dots. Then I look under the x term and I see a 4, so I'm going to go plus or minus 2 in the x direction and make my rectangular box. Sorry about the bad straight lines, I haven't figured out how to use a straight edge on the tablet yet. So then you make diagonals with a straight edge, yours will be. And you'll also remember to label your x and y axes. So if I look at my picture, I can already see the equation of the asymptotes. So I'm going to do that first. So I find the asymptotes first. So the slope is up 4 over 2. Well, 4 over 2 equals 2, right? So it's y equals 2x and y equals negative 2x. Those are the equations of the asymptotes. Okay, then next let's talk about the center. This one's easy to see that the center is 0, 0. We're starting easy. Then the transverse axis, let's see, the y term is first. So I know the transverse axis is going to be the y-axis. So I know this point is a vertex, 0, 4. And the point 0, negative 4 is the other vertex. So the vertex in the upper part is 0, 4, and in the lower part 0, negative 4. Now I can draw my graph. Make sure it looks like it's approaching the asymptotes. It has to approach the asymptotes. So we've got the transverse axis, we've got the vertices, so now we've got to figure out the foci. Well, little c squared is going to be the sum of the denominators. So I don't care which one's called A and which one's called B. Little c squared is the sum of the denominators. So c squared equals 20, and c equals plus or minus 2 root 5. So that's going to be between 4 and 5, and we can see which direction we need to go because the focus has to be on the transverse axis. So we know we're about up here at 0, 2 root 5, and down here at 0, negative 2 root 5. So those are my focus points, 0, 2 root 5, 0, negative 2 root 5. Okay, so let's look at number 36. Number 36, we don't have the 1 on the right-hand side, so we need to divide both sides by 4 because you must have the 1 on the right-hand side before you try to figure out how big the hyperbola is. So I'm going to have x squared over 2 minus y squared over 4 equals 1. So in the x direction, I'm going to go plus or minus root 2, which is about 1.4. And in the y direction, plus or minus 2. That may help to label these points if it's hard to tell on your graph. So now I'm going to find my asymptotes, because I can already see those by making my rectangular box. Drawing my asymptotes. And I can see that the slope is up 2 over root 2. So you need to simplify that to root 2. So the asymptotes are y equals root 2x and y equals negative root 2x. So we've got the asymptotes. The center, again, is 0, 0, because these are the easy beginning problems. Now we need to look at the order of the terms. The x term is coming first, so that means the x-axis is the transverse axis. So I know these are the actual points on the graph, and the other 2 dots are just to help me draw it. So I can see that my vertices are root 2, 0, and negative root 2, 0. And then my focus points, I'm going to have to figure out what c squared is. So c squared is going to be the sum of the denominators. So c squared is 6, and c is plus or minus root 6. So that's going to be between 2 and 3 in the same direction as we went to find the vertex. So somewhere about here, this is root 6. Negative root 6. So the focus points are at root 6, 0, and negative root 6